Hello and welcome to Invent Academy. I'm so glad you decided to join me today, and I'm very excited to introduce you to today's lesson, all about memory. We're going to be looking at some of the psychology and neuroscience behind memory, including types of memory, memory theories, where memory comes from in the brain, and why memory is important. But first, let me introduce myself. My name is Katherine, and I'm a neuroscience pre-medical student at the University of Michigan. I love dogs, I have a big dog back at home, and I love brains. Y hablo un poco de español. So what are we going to be talking about today? Well, first we're going to discover what is memory. We're going to look at the earliest model of memory we have, called the Modal model of memory. We're going to investigate a few different types of memory, including sensory, short-term, working, and long-term memory. And we're going to look at memory in the brain. We're going to look at some case studies of real people who we learned from. We're also going to look at a special type of memory called flashbulb memories. And finally, we're going to discuss, so what? Why does this matter? Why are we talking about memory today? Remember that all you need today is your brain and a computer, a way to watch this. You don't really need any notes or anything else. So what is memory? Memory includes the processes involved in retaining or encoding, retrieving, and using information when the original information is no longer present. It's everything from memorizing a phone number to remembering your old teacher's name to remembering how to ride a bike. So who came up with this? The Modal model of memory is the earliest model of memory we have. This model of memory was theorized by Atkinson and Shiffrin in 1968. They're shown on the slide there. This model of memory included sensory, short-term, and long-term memory, which we're going to talk about more later. And if you look at the arrows on the slides, you can see the way that the stimulus moves between these different types of memories. So this is what I noted before in our definition of memory. Retention and consolidation, or encoding, is when we move information from short-term memory to long-term memory so that we can remember it for a longer amount of time. We'll discuss different ways for information to go from short-term to long-term memory and why this is useful to us. Retrieval is when information comes from long-term memory back into our short-term memory. And use is when we integrate information from our sensory memory into our short-term memory and information from our long-term memory into our short-term memory so that we can use it to influence our behavior and actions. So let's talk a little more about these different types of memory. Firstly, we have sensory memory. This is the initial rich stage of memory. It includes almost all of the stimulus you get from your environment, everything you see, smell, taste, touch, or hear. The capacity for this type of information, though, is very fleeting. Iconic memory is all of the visual information we get, and that only lasts in your brain for about 200 milliseconds. Auditory information is everything we hear and perceive from our environment, and that only lasts in your brain for about 2 to 3 seconds. So who discovered this? There was a psychologist named Sperling who did an experiment in 1960 that is now known as Sperling's classic paradigm. He flashed these letters, grids of letters, on a screen in front of patients for a very brief amount of time, and later asked them to recall the letters that they saw. What he noted from this experiment is that even though they were only able to see these things for a fraction of a second, they were still able to recognize at least some of the letters. The results of these experiments suggested that the human visual system is capable of retaining information even if the exposure is very brief. The reason so few letters could be recalled, he noted, was that this type of memory is so fleeting. Yet it still proved that we're able to take in information very fast, lots of information, and some of it can be transferred to our short-term memory. So speaking of short-term memory, what is it? Short-term memory has much smaller capacity. We only remember about 5 to 7 items and can hold them in our short-term memory, as opposed to sensory memory in which we take in almost everything. This type of memory lasts longer though, 15 to 20 seconds as opposed to 2 to 3 seconds, or even shorter. The type of information that ends up in our short-term memory is attentionally selected from our sensory memory and our long-term memory. That means our brain chooses what comes into our short-term memory. So who came up with short-term memory? Well, Murdoch in 1962 discovered short-term memory by performing an experiment in which he asked patients to memorize a list of words. He then, from this, created a graph from the data called the serial position curve, which shows that we remember more of the first words on the list and the last words on the list, as you can see by the different peaks in the graph on the screen. But the information in the middle is harder to remember. So why is this? Well, he was able to determine that the reason we remember words at the beginning of the list so well is because we have longer to rehearse those words. That means repeating them over in our brain to encode them into long-term memory. So the words that we hear first have a greater chance of making it into our long-term memory and are easier to recall. Why do we remember the words at the end of the list so well? Well, that's because of something called the recency effect. Those words are still within the 15 to 20 second time frame of our short-term memory where we're able to remember things well. So the things that we don't remember as well in the middle either were things that we heard or saw more than 20 seconds ago, which means that they've already left our short-term memory. But they haven't been in our memory long enough for us to rehearse them and encode them into long-term memory. So this explains a little bit about how we're able to understand how long short-term memory is and able to explain how information from short-term memory makes it into long-term memory. So working memory is very similar to short-term memory, but typically we do something with our short-term memory. So two men that are shown on the screen named Baddeley and Hitch in 1974 came up with a theory of working memory, which is a limited capacity system for temporary storage and manipulation of information. In this model, they included the visual spatial sketchpad, the central executive, and the phonological loop. Now those are big, weird words, but basically the phonological loop talks about spoken and written material. The visual spatial sketchpad involves visualizing images like a cube, so then you can then rotate it in your mind and see pictures in your mind after that information has already left. And the central executive directs your attention and it allows you to, for example, drive and talk on the phone and navigate all at the same time. It selectively attends what goes from sensory memory to short-term memory, and it directs control processes on material once it's already in the short-term memory. It also controls the suppression of irrelevant information so that we only focus on what's important to us. Later, a component called the Episodic Buffer was added to this theory, which helps us to explain how we understand spoken language. The episodic buffer holds information for longer and has a greater capacity than the phonological loop in the visual spatial sketchpad, and it acts as a backup store that communicates with working memory and long-term memory. The reason this helps us understand spoken language is because to understand what someone is saying in the present, we often also need to know what they said a while ago, which is why the episodic buffer makes sense, because it has a greater capacity and is able to hold information for longer than the other types of working memory. So the final type of memory that we'll talk about today, barring our special type of memory we'll talk about at the end, is long-term memory. So long-term memory has an indefinite capacity. It doesn't hold 5 to 7 items of information. It doesn't hold everything that we see or hear or experience in our environment. But it does hold what we're able to encode into our long-term memory. And there isn't really a limit to how much we can remember as long as we put it all into our long-term memory. And it also kind of has an indefinite duration. You can remember things from 20 seconds ago to your earliest memories. It includes information about past events and things that you've learned. So a little more about the types of long-term memory. Long-term memory includes explicit memory and implicit memory. These are also often called conscious memory or unconscious memory. In your conscious or explicit memory, there's episodic and semantic memory. Episodic memory includes events and experiences, such as your first day of school, or your first kiss, or your brother's graduation. They're important moments in your past that are played like a movie in your mind. Semantic memory is more like concepts and facts, like knowing the grass is green, knowing Michigan is a state, or knowing who Shakira is. Implicit memory, on the other hand, is other more unconscious parts of your memory, such as procedural memory, how to do things, how to tie your shoe, how to ride a bike. Priming memory is when stimulus exposure affects responses to a later stimulus. To simplify that, it's using the word red to remember apple, or green to remember grass. They're different cues that you encode into your long-term memory that help you then to remember more things later. And finally, emotional conditioning, or classical conditioning, is when you begin to associate different stimuli due to experience, and that is encoded in your long-term memory. For example, if you eat a really bad seafood meal, maybe the next time you smell that meal, you become queasy. And that's because, due to experience, you have developed a specific response to a specific stimuli. All right, so let's look at some case studies of memory and the brain. Clive Waring was a patient who had encephalitis. Encephalitis is when your brain begins to swell because the fluid is expanding to different parts of your brain and it causes damage. This type of encephalitis specifically damaged the hippocampus, which is important for long-term memory. He was then able to remember things in his short-term memory, but he essentially woke up every few seconds because he couldn't remember things for a very long time. So his wife would get home from work and he'd greet her and they'd have a short little conversation. He'd sit down at his piano to play a song and he'd look up and his wife was home and he wouldn't remember that he'd already greeted her. He's essentially constantly living in the present. A different patient called KF has the opposite affliction. They have impaired short-term memory, but intact long-term memory. This is caused by parietal lobe damage due to an accident. This is more like the type of memory you see in the movie Nemo, like Dory. They can't remember things that just happened, but they can remember things that are important that they've known for a long time. A different patient called KC has impaired episodic memory. This was caused by a motorcycle accident that caused them anterograde amnesia. That meant that they could remember things with meaning, like they knew the grass was green, and they knew that in autumn there are leaves, but they couldn't remember important specific things that happened to them, like their last birthday. And finally, there was an Italian woman that had impaired semantic memory, also from encephalitis, in which she could remember specific things that happened, but she couldn't remember the meaning associated with them. Semantic often means meaning is involved. And so she couldn't remember the significance of a war. She could remember that it happened, but she couldn't remember why that was important. So all of these case studies matter because they help us to see that different types of memory are in different parts of the brain. And they can help us study these different types of memory more because once we've localized where they are in the brain, we can do more research on that specific part and we can learn more about how to improve these different types of memories. So case studies are super interesting. So finally, I want to talk about a fun little type of memory called flashbulb memories. In 1977, two psychologists named Brown and Kulik coined this term. So these are memories that are very powerful, emotional, surprising, and they're imprinted into your long-term memory immediately. The stereotypical example of a flashbulb memory in the USA is 9/11, when the planes crashed into the buildings, and it was horrific and terrible. And many people who experienced this event seem to have a very vivid and emotional memory involved with this. And they seem to remember it like a movie, like it was yesterday. So flashbulb memories are very impactful because we believe that we can remember them incredibly well because they were so shocking that they're immediately imprinted into our long-term memory. But studies have actually shown that though we have a lot more confidence in our flashbulb memories, and we believe that we can remember these specific events better than other events, we don't actually. The decay and the forgetting for specific memories versus specific normal memories versus flashbulb memories is actually the same. So don't trust your memory as much as you want to, even if you think it was super vivid. So what? Why is memory important? Well, almost all other cognitive processes depend on memory. We basically couldn't do anything without memory. If we don't understand the meaning of things, if we don't understand how to do things, then we'd constantly be walking through life totally confused and having to relearn everything that happens to us. When we learn about memory, we can also learn how to improve our memory. This is important for learning and for getting through life. So I have a few fun tips about how to improve your memory. These are also called in psychology encoding processes. So one way to do this is to elaborate. When you're studying, associate new material with prior knowledge. Assign meaning to the things that you're learning in school. Don't just try to memorize things. Try to associate something with them. Generate and test. Information is better remembered if it is generated from your own mind rather than simply read. Don't just review your notes and read over things. Try to think about it of your own accord and to generate it straight from your memory. Organize. Making categories of the topics you're studying is really helpful. When you can associate different categories and tie different topics together, it's a lot easier to recall all of them at once. Take breaks. There's something called the spacing effect, where your long-term memory is enhanced when learning events are spaced apart in time. Another way to take a break is to sleep after you study. Let the information stay in your brain and get enhanced by spacing apart the different things that you learn. And also avoid the illusion of learning. This ties back to what I said about just reading over your notes. Being familiar with something and feeling like you've memorized it a little bit doesn't mean you understand it. Make sure that you're assigning meaning and generating information of your own accord when you're studying something. So I have some sources here, and I want to say thank you so much for joining me today at Invent Academy. I hope that you learned something really awesome. And remember that memory is super cool. Thank you so much.